Hello friends, myself Rajendra Mahajan presenting my one more video on area by double integration. In last example, I have discussed the problem of Cartesian type. Today I am discussing problem of polar form. Let us solve the problem. Find area of one loop of the curve r is equal to a into cos of 2 theta. This curve already we have discussed in that chapter of curve tracing. The first step is we have to draw the curve. It is not the problem of curve tracing. We require that figure here. Symmetry of that curve is about initial line. As theta is replaced by minus theta, there is no change in the curve. Therefore, symmetrical about this initial line. Theta is equals to 0 degree. Then points on that curve, when theta is equals to 0, if we substitute cos 0 is 1 into a, we get r is equals to a. Therefore, this is the point on the curve whose coordinates are r, a and theta 0 degree. Okay. Then we take for pi by 4. When theta is pi by 4, 2 times pi by 4, it becomes cos of pi by 2. What is the value of cos pi by 2? It is 0, and therefore r becomes 0. Okay. Therefore, we get the pole as one of the point. Then in between 0 and pi by 4, we consider the another value as pi by 6. Means 30. 2 times pi by 6, it becomes pi by 3, cos of pi by 3. And what is the value of cos pi by 3? It is 1 by 2. And therefore, that point becomes a by 2. Therefore, somewhere here, approximately, we can show that point. Therefore, join this 1, 2, 3 points smoothly to get half part of that curve, and then symmetrical half part about the initial line, so that we get this loop. And all of you are knowing that there are, as n here 2, even number, there are 2n loops, means 2 into 2, that is 4 loops. But as this is not the problem of curve tracing, I am showing only one loop. Like this, we have another loop here, third loop and fourth loop. But that is not the problem. We have to obtain the area of this one loop only. Okay. Then, as it is the problem of area for polar curve, area is given by double integration of r dr d theta. That is the equivalent value of dx dy. That dx dy we replace by r dr d theta. And in polar form, your first integration is always with respect to r, and then with respect to theta. Okay. Therefore, we have to make a elongated strip like this. I have shown that elongated strip in red color, whose lower end is on the pole and upper end on that curve. What is the equation of this curve? It is r is equal to a cos of 2 theta. And I am considering this half part of that curve above the initial line. And then we can make it twice to get the complete area. Therefore, here I am making twice. Then, at this point of that strip, r is 0. At the other point, as it lies on that curve, equation is r is equal to a cos of 2 theta. Then, we have to move this strip from theta is equals to 0 up to this line, that is theta is equals to pi by 4. Therefore, the limits for theta from 0 to pi by 4. that gives the area of the upper part only. We require the complete area, therefore we make a twice. This is that limits for the double integration to find the area. Important one is the figure. Without figure, if you draw this limits, then it is meaningless. No marks will be given. Therefore, first step must be always the figure. Show the point of intersection, all this. Elongated strip as it is a polar curve. And then get the limits with the help of that strip only. And the movement of that strip. Between theta is equals to 0 to theta is equals to pi by 4. And then evaluating it as usual. Therefore, as already I have mentioned that first we have to integrate with respect to r, means that 2 as it is, theta is equals to 0 to theta is equals to pi by 4 d theta, and then integration of r with respect to r from 0 to a cos of 2 theta. This is the order in which we have to perform the integration. We go from right to left direction. Means first our integration, whatever the result, then we have to integrate with respect to theta and then substitute the limits. And therefore, it is 2 times integration from 0 to pi by 4. Integration of r is r square by 2. Limit from 0 to a cos 2 theta, and then its integration with respect to theta. These two to get cancelled. We get integration from 0 to pi by 4. Subtracting the upper and lower limit. Upper limit, it becomes a cos 2 theta square. Means it is a square cos square 2 theta upper limit minus lower limit as 0, and then its integration with respect to theta. Okay. Remaining is a square cos square 2 theta. A square is constant, we can take it outside the integral sign. Integration from 0 to pi by 4 and cos square 2 theta d theta. We call this equation 1. Limits are 0 to pi by 4. If we have to apply that reduction formula, limit must be the 0 to pi by 2. Then only we can use that reduction formula. And therefore, we use the substitution 2 theta as some new variable t. Differentiating it, we get d theta as dt by 2. Transferring that 2 to other side. And we get the new limits. For theta is equals to 0, when we put theta equals to 0 here, t becomes 0. And when theta is pi by 4, we get t is equals to 2 times pi by 4. Means it is pi by 2. Substituting this information in equation 1, equation 1 becomes, therefore area is equal to, it is a square, new limit for t is 0 and upper limit is pi by 2, and cos square 2 theta. What is the value of 2 theta? It is t, and d theta is dt by 2. Okay. 1 by 2 we take outside the integral sign. It is a square by 2 integration from 0 to pi by 2 cos square t dt. We call this equation 2. limit 0 to pi by 2 means, and here it is cos theta raised to m. Therefore, applying that reduction formula, we get area is equals to a square by 2 as it is, no change. Here the value of n or m, whatever we call, it is 2 even number. First term is n minus 1 upon n. Therefore, 2 minus 1 we get 1 by n, n is 2. This is the last term. And into k, k is, as it is even number, we have to multiply it by pi by 2. And therefore, simplifying it, we get answer as pi a square divided by 2 to the 4, 4 to the 8. Therefore, pi a square by 8 square units, as it is the problem of area. It is square units as the final answer or the value of that area. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for such type of new videos, please press the bell icon. Thank you. Thanks for watching.